Hello guys, this time I'm going to show you how to do this effect, destroying this nice wooden pier, shattering everything in the shape of wood splinters using Pulldownit plugin. So let's start. This is our model. By the way, you can download the model from the Badking website. It is made of different parts, and we are going to start by shattering the deck. So for this, anytime we want to create a dynamic crack, we should start by drawing a path over our surface. So let's go to top view, go to shapes, and draw a line over the deck, more or less where we want it to crack. Okay, and now make sure our cube is placed over our surface. So let's place it over the surface so we can see it. And now let's go to shatter the deck model. So select window, select our path. Usually we should use path-based art style, but the problem is path-based is not going to shatter in the shape of the splinter. So let's see it. Select path-based art style and click on adjust the points so they fit the cube, and click on shatter it. So you see these aren't actually good splinter shapes. So let's undo all, and let's select wood splinters art style. Anytime you want to create good splinter shape, you should use wood splinter shatter. So this is our shatter points. Let's adjust our point cloud as close to the line as possible. Then we can refine our fragments, no problem. So let's adjust it and shatter our model. Okay, here we are. We have created our long thin wood splinter, and now let's go to create more of them in some areas. Okay, to make a smaller splinter here and there. So for example, let's select this one, click on preview, and for reshattering, let's reduce the number of fragments to just about 20 fragments. Okay, because we don't need so many of them. Let's shut it, and here we are. We have created more little splinter in this area. Let's do the same in other areas, especially in the borders of our deck. Click on shut it, and see more smaller splinter has been created in the border. Let's create more of them here. Okay, and this is okay, something is wrong here, so let's undo the last operation and shade it again, making sure our points are in the border of the model. So here we are. Now it works. More splinters in this area. So this is the way, just creating more fragments in the areas you want more shavings, little splinter. Let's create a few more of them, and then let's go to destroy the deck dynamically. So let's go with dynamics. First thing, we have to set the rest of our Pier as static objects in dynamic. For this, select all of them, open PDA rigid bodies window and set them as static. Data blue. Make sure we have selected all of the objects. Okay, so our wood splinter collide with them when breaking. So we miss those bins here to include them. Everything is fine. Let's go to the other side. Select the object and make sure we have include them in dynamic as static rigid bodies. One, we missed it. Okay, this one as well. This is okay. Include this one as static. Okay, everything is set as static now. So now let's go to create a fracture body for our deck. For this, just open PDI basic fractures window, select any of the wood splinters. Okay, click on create fracture body, and in the setup fracture body window, this is our selection of fragment. Just click on OK. The model turn orange, that means the fracture body has been created. And now when computing dynamics, okay, we can see everything starting to collapse and break. Nice, but we want the deck breaking when colliding with breaking along this path. For this, we have to do another thing, that is creating a cracker object. Select our path, open PDI crackers window, and now click on new cracker. This little sphere is going to be our cracker object. And now when let's open PDI basic simulation options, and now let's also set viewport to not hide geometry never. Okay, to see the extrusion correctly. Now, okay, our cracker object is colliding with the deck and breaking it, but we have to make some adjustment. Make our deck object as static, and propagation scheme set it to local to break when colliding with the cracker object. Now it is better result, but still it starts to falling before actually colliding with the little sphere. So we have also to set it as activation break upon impact. Let's play it again. Okay, now it's perfect. The deck is breaking just when colliding with the little sphere. Of course, you have to hide this cracker object from rendering, for not seeing it in the final frames. Okay, so we are almost done. We have destroyed our deck with Pulldownit. We have also to move down this the path, because it is colliding from above, and it is more realistic effect breaking it from below. So let's move the path down a little and compute dynamics. Okay, now I got more repelling the extrusion of the deck, okay, and the wood splinter are colliding with the supports on the sides, okay, very nice. So the extrusion of the deck is done, and we are going to continue by adding more detail on this extrusion effect by destroying other parts like those beams and support here. For this, what I do is select those objects and create we have to shatter them and create a fracture body for them. To make it in a easy way, I'm going to create a layer only for those objects. Okay, so open layers and let's create a layer only for those objects here. Click on create new layer. Can name it as I don't know, beans. Okay, so now we can hide the rest of the elements in the scene. It's not here. Okay, not here. Okay, it's the other side. Have to click here to hide the other elements, just to see clearly where the object we are going to shatter at this moment. So let's go to shatter then also in the shape of the splinter. For this, as before, select wood splinter shader style, click on preview, but this time the wood splinter is going to be created across the object, and we want them to be along, so change axis to longest and click on shatter it. We create our wood splinter, just a few of them. We can create more later. Okay, make the same here and the same in the other beam. Okay, we have our wood splinter created, but we want to create a little more of them on the side, so let's select any of them, move the point cloud near the support, okay, to create more splinter in this area. Make the same with the support. You can modify the width to make them bigger, okay, and let's make the same in this object. Place our point cloud near the support and click on shatter. So we create more splinter, smaller splinter in the corner of the three objects. So now let's create a fracture body. For this, select all of them and click on create fracture body. Now click on OK. The fracture body has been created, and now we are going to set the way this object is going to break. First, set it as static so it doesn't move before impact, and now in advanced fractures we are going to set the frame at it should start breaking. For this, let's see that let's go to perspective view. We can see our deck is breaking and reach our this column at about frame 25. So the object should start, this support should start breaking at frame 25. So for this we have to use advanced fractures to make this object start breaking exactly at frame 25. So let's reset the scene, switch on stresses view, but to see this clearly I have to hide the materials. Okay, so let's show object colors in place of material. So now you can see, switch on stresses view, the model turn white and blue. These are the areas where it is going to break. Open PDA Advanced Fractures, and now let's select those fragments here in the middle. We're going to break, select them in the viewport. Okay, they are light blue. Don't mind if you select object behind, because we are working, PDA knows we are working in this object. So click on Create Cluster. The cluster has been created, and now set the shutter hardness to 0 to make sure it breaks completely. Then breakable at frame, set break frame 25, the frame when we want it to start breaking. So this is our cluster, and for the rest of the fragments, we are going to set them as static, so they doesn't move in dynamics at all. They collide but they doesn't move. So select them, they are light blue, and set them as static. Now they are black. That means they are not going to move in dynamics. Okay, something is not working here. Let's for selecting the fragment on the other side, let's select them one by one. Okay, still not working. Select them. Okay, now I think it is going to work. Select them and click on set static. Now here we are, they are black. So our cluster is going to break at frame 25, and the rest of the fragment shouldn't move in dynamics. Let's hide the rest of the object to see clearly our fracture body. Okay, now our static fragments and our cluster breaking exactly on frame 25. So let's switch off stressless view and hide everything to compute again dynamic and see our result, adding the extrusion of this support of the pier. So let's go, let's play dynamics. Okay, the deck is breaking. Again, it is collapsing. Great. But the thing is starting to fall, to collapse before colliding with actually the frame 25. This is because we have to set activation break upon impact for our fracture body. Now it is working. It starts to break only when the cracker reach frame 25. So perfect. Let's finish the simulation and check it. Okay, let's play back our salt. Select our cracker and hide it to see clearly the extrusion of the deck. Okay, now it's breaking the deck and also the support on the side. So it's a matter of make the same thing with other support if you want to add more detail to this extrusion. It left still to destroy. You can see the rope over the support. It is not breaking. Let's ungroup those ropes. Okay, and select this one. Let's isolate it. Well, this is a rope. We should simulate it with a cloth solver or something, but as this tutorial is about Pulldownit, we are going to simulate destroy it also using Pulldownit plugin. So let's click on preview and click on shade button. Now we have create shard for this object and create another fracture body for the rope. This time name it as rope. Okay, so let's set it also as a static. Okay, let's show the whole set and set it as a static, breaks upon impact as before, and let's see how it works in dynamics. Okay, so now it is starting to fall and break. So, well, it's a rope. It is breaking as a solid object, but as we see it in the distance, it works pretty well. So, great. So let's finish the simulation and check the final result. Our deck breaking, the support breaking, and also the rope in the support breaking exactly when we want it to start breaking. So everything is breaking and colliding in a realistic way. Let's play our final result. Okay. This is our final result. Of course, if you want to add more elements in the extrusion, you have just to do the same. Select the objects, shatter them in wood splinter, and add them to the simulation as fracture bodies. So now is a good moment for saving the scene for moving forward. So save the scene with dynamics computed. Okay, save it, and now it rests only to replace this green material here. This is the PDA cut material. It's applied by default to the inner faces, the faces created when shattering the object. It is flat and green by default, but we have to add some roughness to it to make it more believable. And we can, with Pulldownit, we can add jaggedness to the object. Open this. First, we have to let's go to delete all PDI bodies. Okay, to let only keys on the scene. Now there are only keys on the scene. You can play back and forth. Okay, PDA data is gone, and now let's add more detail to the splinters by adding jaggedness to the inner faces. For this, just select any of them, open Add Jaggedness window, select the object, and click on Add Jaggedness. Go to the first frame after applying jaggedness, and you can see now we have much more detail in all the faces of this element. Okay, more rough faces, twisted edges. So we have to do the same with each element broken in simulation, just by selecting any of the splinter. Okay, just one. We have just to select one for each element. Select this one, for example, and click on Add Jaggedness, and now this part of the beam. Okay, the beam here is more realistic now. So let's make the same with the rest of the elements. Add jaggedness to all of them. Select this splinter here and click on Add Jaggedness. Now you can see we get twisted edges. Can even increase or reduce the amount of jaggedness. Okay, it's a very nice feature of Pulldownit. So now when playing the simulation, we get those rough faces more realistic look for our wood splinters. Okay, so now let's continue adding jagginess to those elements in the same way. Here is less evident, but the jagginess has been added to the deck. I think so. Let's check it. Okay, I have to increase it is added, so it is too smooth, so I have to increase the strength of the jaggy effect for those fragments in the deck. Okay, increase it. Let's increase it still a little. Okay, now it is more evident. The jagginess has been applied. Much nicer now, the look of our wood splinters. So we are done with jagginess. Now let's go to replace the green material for a more realistic one. Let's play the simulation with the jagginess applied. Okay, let's see the difference. More realistic look now. Okay, everything has jagginess. So let's go to replace the green material for a more realistic material to finish our scene. Okay, let's place it in a more interesting point of view. Okay, so let's replace this green material for a more realistic one. For this we have just to select, open the material editor, and this is here the PDI cut material, this green sphere here, and this time we are going just to change its color for a more brown, dark brown color. This is enough for the tutorial. Actually you can replace it for the material you prefer, but it's enough for the tutorial, and actually it works great also for rendering because of the roughness we have added already to the faces. So let's replace it for a darker, more good light color to the splinters. Okay, I think it's fine, and let's play the final result with Pulldownit. Okay, here we are. Thanks for watching. Bye.